But let me just give a little bit of review. About exponential equations. So let's see this example with 3 raised by x plus 2 equals 7. What do? Solve exponential equations. So take logs on both sides. So we put the logs on one side because we have equation. We can do the same operation on both sides simultaneously. So we put the logs on both sides. LOG means regular log. That means base 10. And usually for calculus class, we do ln. ln means base e. So by doing so, we can bring down the exponent. So bring down x plus 2 to the front of log. So that becomes multiplication. Then we can divide log 3 on both sides. We subtract 2 on both sides. So we get x equals to log 7 divided by log 3 minus 2. We can use one of the log properties to rewrite log 7 divided by log 3 to be log base 3 of 7 minus 2. We don't have to approximate. But if you want to see what kind of value, right, you may consult with calculators to say, okay, approximately that equals to negative 0.2285756, right? But for me, this step is not necessary, right? X equals log 7 divided by log 3 minus 2 is a perfect answer. It's a perfect answer because it's exact. Right. Okay. So we talk about solving exponential equations. We went over some examples, and this one is quadratic equations, right? And this one we factor out the common factors, right? I think some of us are ready to present, so I'll give the time to you. Then later on, we're going to talk about solve logarithmic equations. Let's see. So Arlie, I think Sarah, okay, Arlie wants to present homework 1347. Great. Let me make you a presenter. Get yourself ready. Rina 53. Rina. Great. Then Ola 18, homework 12. Tijeta. James. It's okay, Ola. Yeah, you can change the number. Sarah, oh, Sarah. All right, I have made you guys presenters. So get yourself ready. Jeremy. What about Elizabeth and Samir? Right, anyone is ready? Okay, Elizabeth. Good. Oh, right. Let's see. Make sure we choose different ones. Jeremy has 53. No, Jeremy, Rina has 53 already. So Jeremy, you need to choose another number. Yeah, let's try. Right, Sarah. Yes, let's try to follow the order. Let's see. First one. Okay, Arlie, I see you are the first one. You have homework 1347. Your first one in the chat. Your numbers appear first. And then Sarah second. Rina third. Ola fourth. Tijeta 5. Jeremy 6. Lisbeth 7. Okay, let's try to follow that. But if someone needs a little bit more time, you know, That's okay. Another person can go forward. Okay, this is Arlie. Are you speaking? I cannot hear you yet.
Sorry about that.
It's okay.
So pretty much we have two logs of the same base and they're adding together, you would multiply them. So what I did is x times x is x squared minus x equals x4. Since they all have the same base, I subtract x4 into minus x squared equals, x squared minus x5 equals 0. I factor that out. X equals x, parentheses, x minus 5 equals 0. From there, x equals 0 and x minus 5 equals 0, which turns to x equals 5.
Okay. So you did homework on the solve logarithm equations.
Yes.
Right. Some of us may, hopefully everybody can understand this. So basically you are seeing we have addition of two logs. We can combine into one log and multiply the value. So you did x times x minus 1. And now since both sides you have the same log, well, what's the base of this log?
Base 10.
Base 10. So we can ignore that. We can equal the value x times x minus 1, which is x squared minus x equals 4x. Then solve from there, factor the two answers. Let me ask you another question. You have two answers, right? X equals 0, x equals 5. Both of them are solutions. Can 0 be a solution? If x
No.
No, right? Why? Why not?
Is it because it's less than 1 or it can't be?
What about half? We can talk about log half, right?
Mm-hmm.
We cannot talk about log 0.
Okay, yeah, I remember now.
Right? Log 0 is undefined.
Yes.
Right. So the value, the value inside has to be bigger than 0. Half is okay, 1/3 is okay, 1/100 is okay. As long as it's a little bit, it is bigger than 0. But it cannot be 0.
So x equals 5.
Yeah, only x equals 5 is a solution. We have to reject x equals 0 because log 0 is not defined. And especially if we put 0 minus 1, we have log -1. It's not defined, right? Inside log has to be bigger than 0. That's the domain. Make sense?
Yes, thank you.
Thank you, Ollie.
Thank you. Okay.
Good. Okay, next one. Who's this? Jeremy?
It's me, Sarah.
Oh, Sarah. Okay, Sarah.
I don't know why it's showing blank. Let me try something different.
Oh, you need to choose the second one. Share application / screen.
Okay, let me see if I can do.
Probably choose the first one. The first one is share blank whiteboard. Yeah, it's here.
Alright. Can you see everything?
Yeah. So which one you are showing?
I'm showing question 52.
Okay.
So the problem is 2 parentheses 2 parentheses log base 5x plus 2 log base 5y minus 3 log base 5z. So the first step you need to do is to distribute the 2. And then you're going to follow a rule, which is log base a b to c power equals c times log base a b. Then you're going to get log base 5 x to the second power plus log base 5 y to the fourth power minus log base 5 z to the sixth power. Now I'm going to follow another rule, which is log base a in parentheses b times c equals log base a b plus log base a c. Then you get log base 5 in parentheses x to the second power y to the fourth power closing parentheses minus log base 5 z to the sixth power. You're going to follow a last rule, which is log base a in parentheses b divided by c close parentheses equals log base a b minus log base a c, and your final answer is log base 5 in parentheses x to the second power times y to the fourth power over z to the sixth power closing parentheses. That's it.
Perfect. Great. Anyone has any questions? If anyone has any questions, feel free to stop, so jump in. All right, great. Next one.
So I had to solve for x, if I remember correctly, and then the equation is log base 9 x minus 5 plus log base 9 x plus 3 equals 1. So because of the log properties, I can combine them. So it's log base 9 x minus 5 times x plus 3 equals 1, but I didn't write that down. So I before foiling, I put them to the same base because of log base 9. So I ended up with 9 to the 1. And then I foiled x minus 5 and plus x plus 3. Ended up with x to the second power minus 2x minus 15. And since they have the same bases, log base 9 and then 9 to the 1, I can equal them to the same. I can set them equal to each other. So it's x squared minus 2x minus 15 equals to 9.
Now, hold on 1 second. Hold on 1 second. So I'm not understanding the second line. The second line, you rewrite the left-hand side, right? Addition of log, you write into 1 log. So why you change the right-hand side to be 9 raised by 1?
Oh, because I put them to the same base.
But can we do that? You see, this you did not change the left-hand side, right? You just change the form of it. This should be still equals to 1, right? The second line.
Oh, I thought I can change it right away.
Right, you can, right. So this to be 1, the second line of the right-hand side.
So this should be 1.
It should be 1, right? Otherwise, you change it to be 9 raised by 1 would be 9 instead of 1. So this
I can change it. So when can I change it?
Yeah, let me see. I was trying to. Sometimes, when you guys present, it give me a chance to write on it, but sometimes it does not. It's mysterious. Let's see if I can find somewhere. Okay, maybe let's write in the chat. I cannot find it in the. So your second step, you just combine. You just combine the 2 logs into 1 log. 5 times x plus 3. This should be still equal to 1. I typed it in the chat.
But when can I change it to the same basis?
Right, so now, after you rewrite this one, you solve logarithm equations. We want to write it in exponential form. So how do we write this one? Now you're writing x, I think I understand what you're doing now. X minus 5 times x plus 3 equals to 9 raised by 1. You see that? So x minus 5 times x plus 3 equals to 9 raised by 1. Your screen disappeared.
No.
Okay, it's back. It's back.
Okay.
Okay, so let me count it. So the second line is not right. The second line, the right hand side has to be 1. And then this second, 1, 2, 3, 4. The fourth line is not right. The fourth line, the right hand side has to be 1. But the fifth one, right, you're pointing this one. This one is perfect. This one is perfect. You see the difference between this one and the one above, the line above?
No.
No? All right. You see the right hand side cannot be 9 raised by 1. Your point, where your pointer was. This has to be 1. This has to be 1, right? This has to be 1, then you rewrite the log equation into exponential. So that's 9 raised by 1. That's why you have here the underline 9. Then you have x squared minus 2x minus 15 equals to 9.
So you're telling me I skipped this step?
You just read something wrong. So your pointer was this should be 1. Is it possible you can change it to 1 now? No.
But I can change it to 1 after.
Well, only this one you're pointing, only this line you're pointing, the right hand side has to be 1. You cannot rewrite as 9 raised by 1.
But when can I change it to 9 raised by 1?
This line, the line underneath is perfect. Let me see your pointer. Where's your pointer? Can you put your pointer on the
Here.
Yes. So this line is perfect. This line where your pointer was is the perfect rewriting the line above. But the above line, the right hand side has to change to be 1.
So this should have stayed 1.
That's right. That has to be 1. That's 1. So
Okay.
then you rewrite the 9 raised by 1 equals to the value x squared minus 2x minus 15. So this line where your pointer is perfect. It's rewriting the above line. Does that make sense?
Yeah.
Right. So that if right, okay, you just cannot change when it was a log. You cannot change the right hand side. That equals to 1. Okay, then keep going. The answer was right.
So then after that, I equal the whole equation to 0, and I factor, and then I use the 0 property, so that's x equals 6 and x equals negative 4. It cannot be negative because log cannot be negative, so the answer is x equals 6.
Right, negative 4 doesn't work. Right, otherwise we get inside the log will be negative values. Great. Only the type O's. Okay, only little type O.
Okay.
Okay, great. Thank you. All right, so who's next one? Jeremy, right?
I'll go
Okay.
after someone else.
Oh, Ola. Oh, we have James, we have Ola. Well, we have Tijeda.
Yes, sir.
Yes.
My name is Lola. Ola means hello. That's not my name.
I'm so sorry. I apologize. So teach me again. Oh, teach me again. Lola.
Lola. Lola. Lola.
Oh, Lola. Okay, Lola.
Yeah.
All right. Thank you, Lola. I may not remember it. Yeah, sorry. Okay, you can go.
Okay, so I'll be presenting number 13. I can't zoom in. I don't know how it works. Can you help me with that, please? I'm trying to zoom in into, but
Okay, so which one you are presenting? I see in
first
the
one, 13. How do I zoom in?
trying. Oh, I did on my side. I zoom in. You did not see the zoom in. Maybe I cannot
Oh,
zoom your side.
I don't know. It's not working. Okay, I'm just gonna explain myself then. So, I'm presenting number 13, which is the first one. The question is log base 2 of 6 minus log base 2 of 15 plus log base 2 of 20. So the first step is to use the log law 2, which says log base a minus log base b equals log base a divided by b. So that we're going to apply to the question. So we're going to have log base 2 of 6 divided by 15 plus log base 2 of 20. Basically, we're combining the log base 2 of 6 and log base 2 of 15 together, and then add log base 2 of 20. And then next, we're going to use the log law, first log law, which says log base a minus log, wait, hold up 1 second. Yeah, log base a plus log base b, not
Uh,
mine, I made a
great.
mistake,
Yeah, great.
plus log base b
Uh,
plus log base a multiplied by b, like ab. So we're going to apply that to the last equation, not equation, to the last whatever we have. So we're going to apply it to this question, and we the answer we're going to get is log base 2 of 6 multiplied by 20 divided by 15. So basically what we're going to do is multiply 6 and 20, which gives us 120 divided by 15. So 120 divided by 15 is 8. So our final answer is going to be log base 2 of 8. And then since 8 is still the same as, like, we're trying to get the same, make the base and the, what's the number called? No, exponent. Okay. So we're trying to get a 2 so that log base 2 of 2 can cancel each other and like get 1. Not cancel each other, but like we're going to get 1 instead. So we're going to rewrite 8 as 2 to the power of 3. So when we do that, we're going to have 3 as our answer.
great. Great. So you said, but you did not write here. So basically, you have 3 log base 2 of 2. That equals to 1.
1, yeah, then 1 time.
That's right.
Multiplied by 3 is 3.
Then it equals to 3. Right. Great explanation. Right. And you are able to recognize your own mistake. Perfect. Good job. Okay. One thing. Without so math has 2 families: expressions or equations. Here we have expression.
Okay.
When you want to call it, when you want to address it, just say expression. Above expression. Right. Okay, great work. Thank you.
Yeah.
Okay, that's Lola, and we have James. Right. James, Tijera.
I was supposed to go before James, but he can actually go because I was supposed to present what Lola just presented. She was supposed to present homework 12 question 18, and she ended up presenting homework 11 question 13. So I'm gonna have to change my question so he can go.
Sorry, that's why I was a little bit confused. I was
Yeah, because she said she was gonna present homework 12 question 18.
Okay, you can just Tijera, you can just pick anyone. Okay, another one.
Yeah, I could go after them. I would just set it up another the other homework.
Okay, thank you. Thank you. James, are you ready?
Yes, Professor. Just setting up my screen.
Yeah, Lola, thank you. Thank you. You did a wonderful job.
Can you see my screen, Professor?
It's coming up. I don't see your work yet. Oh, yes. Yes.
Okay. Okay, so I'll be doing number 15 from homework 11. Basically, we're evaluating the expression, this one. So, log base 4, 16 raised to 100. What I did to 16 is I made it 4 raised to 2 because I want to cancel 4 to base 4. So, log base 4 4 is equal to 1 since, the logarithm rules. So 1 times 200 is 200. That's about it.
Okay. It's a good, but it's just one step. Okay, let me see. I cannot write on yours. Oh, right. So this 200, the exponents
Yes.
come up front, the log, right?
Mm-hmm.
So if you can write one more step saying 200, so let's see, 1, 2, 3. The third term, log 4 of 4 raised by 200. If you can write one more step, log 4, I'm writing in the chat.
Okay.
If you could write this step, that would be perfect.
But
You see in the chat, I wrote in the chat. If you basically telling head log base 4, 4
that,
raised by 200,
right.
we can move the exponent up front the log.
Yeah, I forgot about that rule.
Right, so that's a very important step. Now log 4 of 4 equals to 1. Then the answer is 200. Okay, all right, anyway, good, James.
Okay, Professor.
All right, so next one.
I could go now, Professor.
Yeah, you go. Thank you.
Okay. So this is homework 12. I will presenting question number 6. I hope nobody chose that. So this is asking to expand the following expressions. So number 26 is log base 6 of 4 square roots of 17. How do you read that 4 on top of the square root, Professor?
Okay, we read like this: fourth root. Fourth. Let me type. Let me type in the chat. Fourth root of, it's 14 or 17? 17.
17, yeah.
Okay, read as this: fourth root of 17.
Okay, log base 6, fourth root of 17. So to expand this, it's going to be a division for sure, and it's log base 6. The number under the square root 17 will be on the top, and then of 4, which is like the square, the exponent, becomes would be the denominator divided by 4.
Okay.
It's pretty easy, just
But let's see, we're missing. But I would love you to show one more step. So show one more step how this 4 appear in the denominator. So fourth root of 17, we can write as 17 raised by an exponent. What is the exponent of 17?
the exponent of 17.
Right.
I'm not understanding your question.
Okay. So the fourth root of 17 can be written as 17 with an exponent, with a fraction exponent.
1?
Okay, can you see in my chat? Fourth root of 17 can be written as 17 raised by quarter.
Okay.
Does that make sense?
Yes.
Right? It's like if it was a square root of 17 can be written as 17 raised by half.
By half, yes.
Right? So
yeah.
So now, so you are written log base 6, fourth root of 17 to be. Can you write one more step there? Right after the question.
Wait, I'm not understanding what you're asking me to do, Professor.
Okay, you need one intermediate step between your first line and the second line. Something very crucial is missing. You know, how did this 4, how did the fourth root of 17 become the denominator of log 6 of 17?
Okay.
That's one very, very crucial, important step.
So since it's log base 6 of, fourth, I don't know how to say it.
Fourth root of 17, yeah.
Yes, fourth root of 17. So I put the 4 on the bottom because usually if there wasn't to be a square root, the 4 would be like in front of the log. So since there's a square root, I just put it on the bottom.
Right. So you see in the chat, I wrote fourth root of 17 to be 17 raised by quarter, right? So now your log is log 6 of 17 raised by quarter. So now how do you write it?
Okay.
Now how do you rewrite it? Log base 6 of 17 raised by quarter. Now what happens with the quarter?
The ones you get eliminated, no?
What do you mean you get eliminated? Let me write here. So your question is log, oops, why can I write? It's log base 6 fourth root of 17, right? You did the calculation in the end, you said, okay, that is log base 6 of 17 divided by 4. The answer is right. But you cannot jump, right? It's like from your home. You cannot just jump from one place to another place. That's a very crucial intermediate step. So
okay.
I suggest you to rewrite the fourth root into exponent. I said I could rewrite the fourth root of 17 to be 17 raised by, you tell me what power? Fourth root we can rewrite as power
1/4.
1/4. Now what happens? So inside the
We
log,
bring down the 4.
you bring down, we don't have 4, what do we have here?
Oh, 1/4.
We bring down the quarter.
Yeah.
We bring down the quarter to be in the front of log. So we have 1/4
Log base 6.
log base 6 of
17.
17. Now this term you can rewrite as log, because 1 times log base 6 of 17 is log base 6 of 17 divided by 4.
Mm-hmm.
Okay, so those two steps are very crucial. You cannot skip it.
Okay, I understand.
All right. Okay, thank you.
All right, thank you very much.
Okay.
All right.
All right, next one. Next one, Lisbeth, right? Lisbeth and Jeremy.
Yeah,
okay.
Okay, so I'm going to be talking about or presenting the homework 12 problem 30. We are required to solve the equation. So basically we are given e raised to this 2x power minus e raised to the x minus 6 equals 0. This is our equation. So the first step that I took was to factor the left side of the equation. So in this case, it was e raised to the x minus 3, and then e raised to x plus 2 equals 0. And when we multiply this, we go back to this. So this is just like a factor version of our given equation. This is because we want to set the individual factors equal to 0. So I'm going to start talking about or solving for the e raised to the x power minus 3. So it's already equal to 0. And basically, I am going to now add 3 to both sides. So I can cross out the minus 3. We then take the natural logarithm of both sides of the equation to remove the variable. So, okay, so this is the natural logarithms of both sides. Then here, so we can expand basically ln e raised to the x power. We have to move x to the outside or the front of the logarithm. So this exponent here is now in the front of the logarithm, basically here. And we know that the natural logarithm of e it's 1. So the next step here was to multiply this or replace this by 1 equal to this is the same, this does not change. So then we divide it by 1 and we cross it out, and we basically leave the x alone, which is our goal. So x equals ln parentheses 3. This is our solution for this first factor. Now, this is our second one, and by just doing the inverse operations on both sides, meaning subtracting 2 on both sides, we can already know that this equation, we don't have to even go further than that because this is undefined. This has no solution. So why? Because it's a negative number basically. So I think this is it. We have one solution and the other one is not a solution.
Good job, Elizabeth. Yes, e to the x can never be a negative value.
Yes.
Yeah. Great explanation as well. Good job.
Thank you. I'm working on it.
Yeah, thank you. Good job, guys. I'm feeling very proud of you guys.
I'm ready.
Okay, go ahead, Jeremy.
You see it?
It's coming up, I think. Yes, see it.
Okay. So mine is it's pretty simple. I had to like just use a calculator a little bit. It's about compound continuously, like with the interest rate of $1,000. Basically, what I did was a to the parentheses t equals to pe to the power of r. See? And then I substituted it.
Jeremy, can you remind us of the question itself?
Like,
What do
okay,
we
sure. Sure. It says doubling an investment. How long will it take for an investment of $1,000 to double in value if the interest rate is 8.5% per year, compounded continuously?
Okay, great. Thank you.
So, yeah, I basically substituted everything, and then I divided 0.085 to both sides, and then yeah, eventually I got 8.15 years, around 2 decimals.
Okay. Right, so you're using, because it's continuous compound, so you're using the formula of A of t equals to P e raised by T and R.
Yes.
The interest rate is 0.085, so it's 8.5%.
Yes.
The initial amount is 1,000. So trying to double it to find how long it takes to double it. So you said 1,000 equals to, so you set up, you put all these knowns into the formula. In the end, it's solve for t. To solve for t, you're saying, okay, let's take logs on both sides using ln. So then 0.085t equals to ln2. So you use the calculator, you find t is about a little more than 8 years. All right, great. Anybody has any questions? Okay, good job, Jeremy. Thank you.
Thank you. No problem.
Okay, next one.
Professor,
Yeah.
can I present 32 for homework 12?
Yes. But if nobody, I don't remember all those presented ones. Show us. Maybe nobody.
Yeah.
Yeah.
Get the screen ready.
Yeah. I made you a presenter. So after Samir, let's see. Yeah, after Samir, anybody else? Or Natalie?
All right, ready?
Yeah, which one you are presenting?
32.
Okay.
Homework 12. So for this question, we're basically solving the equation, and we have e to the x minus 12e to the negative 1x minus 1 equal to 0. So I basically just rewrote it, wrote the examples step by step, and I start off by writing e of x to the second power minus 12 minus cx, and since we have a square here, I decided to just split the ex minus 12. So I split the 12, negative 12 with negative 4 plus and the 3, and then I did it, I subtracted negative 4 by adding 4 to both sides, and then 3 to negative 3 by negative 3, and then I ended up with 4 negative 3. But I'm not sure if in this example we're supposed to use negative numbers as solutions. So I would go towards e to the x equal to 4 better off. Yeah,
Okay.
Yeah.
Okay. It's good, but there's certain basically great. All right. Let's see from the first step to the second step, from here to here. How did you get it from first line to the second line?
Wait, what was that?
How did you get it from the first line to the second line? What have you done?
Oh, I rewrote it as negative ex. I put it into parentheses, and I swapped it basically from negative 12 after that.
I'm not talking about from second to the third. I'm talking about from first line to the second line. Because the first time you have e to the x, right?
Yes.
Now you have e to the x raised by square.
Mm-hmm.
So what did you do to make that happen? Then the first line you have negative 12 e to the negative x. On the second line you have a negative 12. The first line you have a negative 1. The second line you have negative e to the x. So basically you multiply everybody by e to the x.
Yeah.
The
That's
0
exactly what I did.
When you have equation, you can multiply by any number on both sides simultaneously.
Exactly.
0 times e to the x is still 0. Negative
Yeah.
1 times e to the x, you have negative e to the x. 12 e to the negative x times e to the x. E to the negative x times e to the x equals to e to the 0. And e to the 0 is 1, so you get a negative 12.
Okay.
E to the x times e to the x, you have e x squared. All right, so basically from the first line to the second line, you multiply everyone with e to the x.
E to the x.
Right. So second to third, you rewrite it. You rewrite it.
In the form of quadratics, right?
Right, in the form of quadratics. Now let's look about this line. What's missing here? Something's missing. You see, what's your variable here in the above line in here?
Ex.
E to the x, right?
Yeah.
Look at this line. What's missing? Where is
Oh,
your
it's missing ex.
right? You're missing x above e, right?
Oh yeah, I forgot about that.
Right. So now you solve, you get e to the x equals to 4, e to the x equals -3.
Oh, okay.
Right. Well, so e to the x will never be negative number. We just reject this one.
Okay.
Now we have e to the x equals 4. How do we solve this?
E to the 4?
We have e to the x, so you have this one, right?
E to x minus 4?
Right, you have e to the x equals to 4. But we need to
Okay.
solve for x. How do we solve for x? We have e to the x equals to 4. We can
So-
rewrite.
Write it.
Right, how do we rewrite it?
I think it's ex to minus 4 equal to 0.
Well, that wouldn't help. We could write like that, but it wouldn't help us. How do we solve exponential equations? We want to use the logarithm method, right?
Yeah.
Put the logs on both sides.
Also, you have to move the e and the x. I don't remember.
Okay, let's try this. So now we have e to the x equals to 4. Oops. We have e to the x equals to 4, right? How do we solve exponential equations? We put logs on both sides, right?
Yeah, the log.
We put log ln on this side. We put the ln on this side. We have a ln e to the x equals to ln 4.
4.
Right, now do you like to try to solve from here?
Ln,
Goal is try to find the x.
so it'll be ln.
We have ln e to the x. What do we do with the exponent of x?
We replace it.
We put it, because it's an exponent of the law
Oh,
of,
we move it to the other side.
we move to the front of ln.
Yes.
So that becomes x
ln e
ln e equals to
4.
4 or ln 4?
ln 4. Okay.
ln 4, right? Because we put ln 4 on both sides.
Yeah.
Okay, now what's ln e?
ln e is
What's ln?
ln is log.
Log
Wait.
base with
Log
what?
base 4.
No, ln is log base 4?
No. Isn't it x?
ln means log base x? What do you mean?
I know. Actually, I don't know honestly.
ln is log base e, right?
Oh.
ln is log base e. So
Okay.
now you have log, so ln e is log base e of e. What's that?
Log base e of e. Isn't it e squared?
No.
Wait, I don't know.
Yeah, right. You need to log base e of e equals to 1.
Oh.
Okay. I'm not going to give you full credit for this presentation. I won't be able to, all right? Because you won't be able to answer these physical questions. All right, but the part of the work are great. All right.
Okay.
Keep it up. Thank you. All right, Natalie, are you ready?
Yeah, I'm ready.
Okay. Andy, you like to show any of your homework? Right, I see
Can
your
you see?
screen. Yeah, I see your screen.
Yeah, I'm showing 34. So this was a question: x squared power x minus x 10 to the power x equals 2 parentheses 10 to the power x. And so I wanted to put all the like terms on this side, so I subtracted 2 to the power 2 in parentheses 10 to the power x on both sides. So we're gonna have this here. And then I factored 10 to the power x out. And I have x squared minus x minus 2 equals 0. And so I factored this out, and I got this, and I further factored it out, and this was it. So 10x equals 0, 10 to the power x equals 0, x plus 1 equals 0, and x minus 2 equals 0. And then I tried to take like log of both sides, but then I realized that there's no log of 0. And so x equals negative 1, and x equals, that's it.
Hold on a second. Right, 10 raised by any value will never be 0. That's no solution of this. X equals negative 1, x equals 2. Okay, great.
All right.
Thank you.
All right.
All right, so anybody else? Okay, so yesterday I made a not yesterday, Wednesday I made a mistake. I went I somehow I went to the classroom too early. So I recorded, but it was a short lesson. So today I'm going to keep talking about solve logarithmic equations. And we know how to solve exponential equations, right? Exponential equations, we isolate the exponential form. Then we take logs on both sides. Let's see this one. We isolate the form, the exponential form first. Okay, for this one, we divide by 8. Then we have e to the 2x equals 20 divided by 8. Then we take logs on both sides. Why we take logs on both sides? Then the exponent, because the variable in the exponent. Then we can take the exponent up front of the log. That's the crucial step. That's a trick to solve exponential equations. Today we're going to talk about solve logarithm equations. Let's see, we have log base 2 of x plus 2 equals 5. So how do we solve this? We want to rewrite this equation into exponential equation. So we can write as 2 raised by 5 equals x plus 2. Right? So we rewrite as x plus 2 equals 2 raised by 5. Those two equations look different, but we can write one in terms of another, right? So basically, these two equations are very, very similar. We can write logs into exponential equation. So the base in the log stays as a base in the exponential form. And this 5 here is exponent of 2. So 2 raised by 5. So 2 raised by 5 equals to x plus 2. Equals to x plus 2. Let me see. Rina, Rina and Samir, does this step make sense for you? Okay, make sure this step makes sense for you. Samir? Okay, so we can always rewrite log into exponent. We can rewrite exponential form into log. Right, so we rewrite the log base 2 of x plus 2 equals to 5. Then we can rewrite as 2 raised by 5 equals x plus 2. Now 2 raised by 5 is 32. So 2 times 2 times 2, 5 times, that's 32. Then x plus 2 equals 32. We want to solve for x, we subtract 2 on both sides. So x equals 30. Oh, I see, Rina, right? Yeah. Okay, great. So the steps of solving logarithm equations is very similar to exponential equations. So first we isolate the log term. We'll isolate the log term. In here, the log terms is already isolate. We don't have to do anything. But sometimes maybe it's not isolated, so we need to isolate the log term first. Then we rewrite the log equation into exponential equation. Then we solve for x, right? Basically, once we write it in exponential form, we can solve for the variable. Let's see some examples. So let's see a. A we have ln x equals to 8, right? Log n means, okay, Samir, ln means log base e, right? Log, sometimes we see only log. If we only see log, that means log base 10. Log base 10 is called a regular log. Log base e is called a natural log, because e is called a natural number. Okay, so ln means log base e. Let's rewrite this. So we will write the base e raised by a equals to x. So that way we can solve. X equals to, so the value inside log equals to base e raised by 8. Now we just leave like this. E is like a pi. It's an irrational number. Just leave this form. E raised by 8 is just a number. Does not care about what exactly it is. But if we do want to know, we can punch into a calculator. It's approximately 2,981. But for our answer, we can leave as x equals to e raised by 8. That's a perfect answer. Right? It's not estimated. Let's see the second one. The second one is log base 2 of 25 minus x equals 3. We can rewrite as 2 raised by 3 equals to 25 minus x. So we write as 25 minus x, the value of the inside the log equals to the base raised by 3. 25 minus x equals to 2 raised by 3. So 2 raised by 3 is 8. Right? We can solve, so we can do negative x, or we can move negative x to this side, it becomes positive x. Move a to other side becomes negative a. So x equals to 25 minus a equals to 17. Right. So once we finish, we can go back to check. So let's put 17 into the space of x. 25 minus 17 is 8. Well, if we evaluate, it does give us a 3. Right. Any questions? Let's see more example. Well, let's see this one. This one, we see the log term is not isolated, right? So the left-hand side, we have a number, we have a scalar multiplied by log. Well, let's try to isolate the log term. So what do we do? First, let's eliminate 4. So we would subtract 4 on both sides. Okay? So minus 4 on both sides. Or you could think, let's move this 4 to the other side. Well, it's positive on this side. When we move to the other side, it becomes negative. Move this 4 to the other side, becomes negative. We have 3 log of 2x equals to 16 minus 4. 16 minus 4 is 12. Now we still have this 3 in front of log. But how do we eliminate? Let's divide by 3 on both sides. We divide by 3 on both sides. We get log of 2x equals to 12 divided by 3, which is 4. Again, this log has no base. Has no base means the base is 10. We rewrite as 2x equals to base 10, 10 raised by 4. So 2x equals to 10 raised by 4. 10 raised by 4 means 1 followed by 4 zeros. So 1,000, 10,000, 4 zeros. 10 raised by 4 means 1 followed by 4 zeros. 2x equals to 10,000. Now let's divide by 2 on both sides. So 10,000 divided by 2 equals to 5,000. So x equals to 5,000. Now we may plug in, well, let's check. Let's put x equals to 5,000 back into the equation. We have 4 plus 3 log 2, log of 2 times 5,000. 2 times 5,000, which is 10,000. 10,000 we can write as 10 raised by 4. Log means base 10. Log base 10, 10 raised by 4 equals 4 times log base 10 of 10. Log base 10 of 10 equals to 1. You get 4. Right? So any questions for this? We isolate the log term first. Then we rewrite into exponential form. Let's see more example. Let's see this example. This example.
Professor, I have a question.
Yes.
Can you go up a little bit where you was right now? Like, yeah.
Yeah.
When you wrote on the side in the blue, I'm just a little confused because yours said equal to 4, and then over here they check 16. So I'm just a little confused.
Oh, this here, you see, what is log?
Yeah.
Log of 2. So this one is to explain this term.
Okay.
Log of 2 times 5,000. I mean, 2 times 5,000 is 10,000. So 10,000 is divided as 10 raised by 4. Right?
Okay.
Then we can rewrite that as 4. So exponent of 4 we can move up front of the log. Log 10. What's log 10? Log means log base 10. Log base 10 of 10 equals to 1, right?
Yeah.
Right, that's the explanation of this. Log of 10,000 equals to 4.
Okay.
Okay, so that's
okay, got it.
explanation of this one to this one. But then when you put back in, right, you have 4 plus 3 times 4. 3 times 4 is 12. 12 plus 4 is 16. Okay.
Okay.
Okay, good question. Any other questions? Amir? Does all this make sense?
Yeah. Good so far.
Let me show if I confuse you. Okay, I'm sure I will confuse you sometimes. Make sure when you feel confused, stop me. I'll try to explain more. Okay, let's see example 8. Example 8, on the left hand side we have 2 logs. Right? We have addition of 2 logs. We want to use the log rule. Addition of 2 logs, we can write into 1 log. So here we have 2 logs. We can write in 1 log. Because it's addition, we can multiply its value. We multiply x plus 2 with x minus 1 equals to 1. Equals to 1. When we rewrite it, we do not change the value on the right hand side. The right hand side is 1. It stays to be 1. Now, what's log 1? Well, what's 1? 1, we can write, actually, let's rewrite this log equation. So now we want to write this log equation into exponential form. So log without base, that's base 10. So that means 10 raised by 1, 10 raised by 1 is 10, equals to the value of log inside the log. So x plus 2 times x minus 1 equals to the base 10 raised by 1. So this is a crucial step, right? So now we can multiply out the left-hand side, that equals x squared plus x minus 2 equals 10. Then we move 10 to the left-hand side. Or we subtract 10 on both sides. We get x squared plus x minus 12 equals 0. Now minus 12, we can split. So this one we can factor into x plus 4 times x minus 3. Right? Because 4 plus negative 3 give us positive 1. 4 times negative 3 give us negative 12. Then we use the 0 property. We said x plus 4 can be 0. That gives us one solution, x equals negative 4. And x minus 3 can be 0. That gives us another solution, x equals 3. So it seems like x has two solutions, negative 4 and 3. But for log, we need to go back to check. So let's check x equals to 4. X equals to negative 4. Let's plug into the original equation. So I have log negative 4 plus 2. Negative 4 plus 2, that's log of negative 2. No good, right? Domain of log has to be positive numbers. So we reject this value. X equals negative 4 is not a solution for the equation. Let's check x equals 3. X equals 3. We have 3 plus 2 inside the log. 3 minus 1, 2 inside the log, both being positive, that's fine. And then when we do the calculation, indeed, we get 1. Indeed, we get a 1 on the right-hand side. So x equals 3 is a solution. So this is like a typical question, right? So we have two log terms. We want to use log property to combine into one log. Then we rewrite the log equation into exponential form. Then we just solve algebraically. All right, let's see. Okay, let's try some exercise. The homework I already posted on Blackboard, and some of you even are able to do some. Let's try. No, let's try some exponential. Let's do it together, exponential and the log, right? Let's try log first. Let's try now. I would like all of you to show, right? Even you make mistakes, that's fine. Let's try from 30, let's try 38, 39, 40, 41, 42. Right. Let's try this 5. 1, 2, 3, 4, 5. Maybe you can try 43 as well, because 43, because homework does not include in 43, 44. So let's add 43 and 44. So basically try 38 up to 44, all right? Yeah, suppose try now. Try now, and hopefully someone can show the work. If you are able to show the work, I'll give you a presentation credits, all right? see 38 up to 42. All we have to do is just rewrite it into exponential form, right? And solve for x. 43, 44 needs a little more work. We need to isolate the log term first, then rewrite as exponential form. And the 44 is a quadratic equations. We have quadratic forms. Okay, anybody like to try 38?
Yeah, I can.
Oh, okay, Lola, thank you.
Wait, I'm supposed to share it or no?
You can tell me, I can read for you.
Okay, so the question is, that's the question, right?
Right, 38, right?
Yeah. So the first thing I did is like try to write the exponential form, and then we're gonna have e to the power of ln in bracket 2 plus x.
E to the power of what?
E to the power of basically what we have in the expression we have in the question. So ln in bracket 2 plus x.
Okay, we have equation. You want to rewrite this in another equation, right? So let me write 2 plus x first. So put 2 plus x equals 2?
2 plus x equals e.
Equals e, great. E to the power 1.
Yeah, I
Right, e
mean,
to the power 1 is e, great. Okay,
yeah.
good job.
So after that, we move the constant to the right hand side, which is basically like minus 2 from both sides to get rid of the 2 on the side to the other one. So we're going to have x equals 2 e minus 2.
That's it, perfect.
And then x equals 0.7183.
Yeah. X, right, x equals e minus 1, that's a perfect answer. We don't really have to use a calculator to approximate.
Okay.
E minus 2 is the exact answer. We can keep
Okay.
as x equals e minus 2. Perfect,
Okay.
that's for 38. Right, anyone has any question? We just rewrite as exponential form. Log n is log base e. We rewrite as 2 plus x equals to e raised by 1. 2 plus x equals e raised by 1. We just solve for x. So x equals to e minus 2. Great. Okay, Elizabeth, 40. I can read for you. You can just explain. Okay, Natalie, 39. Okay, whoever is ready, you can talk to me. I'll read for you.
Okay, so for number 40, so we have log of, well, we know that it's log base 10 because there is like no number there. There's like no base present, so we already know that it's 10. So log base 10 parentheses x minus 4 equals 3. So the first step that I did was I converted it into an exponential, so that is x minus 4 equals 10 raised to the third power.
Perfect. Okay,
Then I just solved for x, and basically 10 to the raised to the third power is 1000. And I did inverse operation, meaning plus 4 on both sides after that. And then, yeah, the answer is 1004.
that's it. Perfect. Perfect. Anybody has any question? Okay, great. That's 40, Liz. And Natalie, 39.
Okay. So I converted to exponential form, so it's x equals 10 to the power negative 2.
Okay. Also 10 to the power of negative 2.
And then x equals 1 out of 10 to the power 2, so 1 out of 100.
That's it. Perfect. Perfect. So we write as x equals to 10 raised by negative 2, which is 1 out of 100. Perfect. Good job. Okay. Rina, 42. Sarah, 43. And maybe someone can do 41. Hey, boys, where are the boys in our class? 42, I can read for you.
Oh, I already shared it.
Oh, you already shared? Okay, great.
Can you?
Yeah.
Okay, so hopefully I did it correctly this time. So I the base to 3 because it's log base 3. So I did it on both sides. And then I kept it as log base, 3 to the third after I removed the log. And then after that, I put 27 because 3 to the third is 27. So minus 2 on both sides, and then it's negative x to the 25, and then divided by 1. Divided by, I don't know why I put negative 1. I meant to divide by negative 1, yeah, that's what I put. And x equals negative 25.
Okay, is this a solution? We put it back into the equation.
Oh, that's not the solution because log can be negative.
Right. No. Well, 2 minus negative 25, it is a solution, right? 2 minus negative 25 becomes 2 plus 25. That is okay. I want to talk about the second line, maybe.
Second line?
Right. Go up a little bit.
This?
Second line. No, the first line.
Oh, this line.
Right, this line. Okay, again, I'm telling you that is a mistake. Can you tell me what's the mistake which you made previously in the previous presentation? Right, exactly where your pointer is.
So it's supposed to stay 3?
Yeah. It has to be 3, right? You cannot change 3 to be 3 raised by 3. Do you see that?
I don't understand when I can change it.
I don't understand why you write a 3 as a 3 raised by 3.
Because the log is 3 on the left side.
The left side, you can write it for the third line. The third line is perfect. But the second line, you see your left-hand side did not change from the first line. So you change your right-hand side. You change your right-hand side from 3 to 3 raised by 3.
Oh, wait, so I can only change it after I remove the log.
Yes, you can only change it after you remove the log. Yes.
Okay. I'm sorry, I didn't know that. I didn't understand when you explained earlier.
I was not able to explain better. Okay.
I'm sorry.
Good job, Brenda. Thank you. Anyone wants to show 31? I mean 41. We have James, we have Jeremy, we have Samir, we have all the boys in class. Jetta. All right. In any case, so I assigned homework. Homework 13 is 45 to 54 right here. 45 to 50 to 54. 78, 79. 78, 79 applications. And Jeremy already showed one. Anyone has any questions? Oh, Sarah wants to show 43. Okay, Sarah. Yeah, let's go.
Can you hear me?
Yep.
So I'm presenting question 43, where the problem is 4 minus log, in parentheses 3 minus x, close parentheses equals 3. The first thing you want to do is to isolate. So I made sure I moved 4 to the right side. So now it's going to be log parentheses 3 minus x equals 4 minus 3. Solve 4 minus 3, which is 1. So it's going to be log 3, in parentheses 3 minus x equals 1. And you apply the rule, which is log base a x, which turns into x equals a to the y power. So that way you get 3 minus x equals 10 to the first power. You solve 10 to the first power, so that way you get 10, and then you have to switch around the equation, so that way you get 3 equals 3 minus 10, solve that, and you get x equals 7, negative 7.
Great. Great. Good job, Sarah. All right. Good job, girls. I'm really proud of you. So the homework, let me show you one more time. The homework, we have those two compound entries. So we need to use the formula for compound entry with finite time and compound entry continuously. And then to practice this 45 up to 45 up to 54, solve these log equations. And 55 is also good. 55 is also a good question to think about, okay? 55 and 56 are fun questions to do.
Okay, so basically it's the same homework as last time, right?
Yeah, it's the same homework as last time.
Okay. And
Yeah,
thank you. Have a great one.
have a good weekend, girls, guys, everybody.
Same.
Okay, very good class.